This next unit will include two things. We'll spend a little bit of time on polygons in general, and then a lot of time on parallelograms specifically. So, first of all, what is a polygon? A polygon is a two-dimensional figure. That means it's flat. It's not three-dimensional. It's made by segments, and the segments only intersect at their endpoints to enclose an area. So I've given you some examples of these are polygons. They're made of segments. They're obviously flat. They only intersect at the endpoints. They enclose an area. These are not polygons. Why is this one not a polygon?
It curves.
It's got a curve. Why is this one not a polygon?
It's got an open.
It's not complete.
It's supposed to enclose an area. Does this enclose an area? No. Why is this one not a polygon? Yeah, because they cross at someplace other than at the endpoints. Or you could say because it's two different polygons. Either one would be fine. The two main types of polygons are convex and non-convex, sometimes called concave polygons. We will almost exclusively deal with convex polygons. Now, some of you know the names of the polygons, some of you don't. If you don't, you need to memorize these. Okay, so just real quickly, let's run through these. What is it called if it has three sides? A triangle. Now with four sides, I usually get all kinds of answers, but I want you to think of the most general one, not the most specific one. A square would be the most specific, but the most less specific than that. Quadrilateral, yes, very nice. And it would be nicer if they had used some sort of system where it was consistent all through, but they don't. Five sides, do you know that one? Very nice, pentagon. Six sides? Hexagon. I always thought that one was easy to remember because 6 is 3 letters that ends in X, and so is hex. 7 sides, Grant, need to be paying attention. 7 sides is what? So some books say septagon. Typically in more modern books, they say heptagon. Eight sides, octagon. You need that for your driver's ed test. Stop signs are octagons. 9 sides. What it? Yeah, it is a nonagon. That's good. Anybody know 10 sides? Decagon. Good. Anyone know 12? So, in Spanish, 12 is doce, right? It is a dodecagon. Now,
Why does this get to 17?
well, once you get past about 12, there are rules for all of those. In fact, you could name any number of sides and there's a rule for naming it, but it gets kind of ridiculous to learn all of them. So when we get up to something like 17, we just call it a 17gon.
You would call it 13 gone too.
Yeah, like I said, there are names for all of those, but once we get past 12, I don't need you to have that memorized.
What about
11
11?
is an undecagon.
I knew that.
Again, kind of like Spanish, where it's 11 is what? Once. It's very close to the way Spanish does it. So if we don't know how many sides it has because there's no picture, sometimes they'll call it an n-gon, where n is the number of sides. So in that, n is the number of sides. And actually, we'll use that throughout this unit. When we're talking about the number of sides, we'll almost always use n for that. So again, if you don't know those, and some of you may have never learned them, that's fine, but you have to learn them now. All right, page 2, you may remember that last semester, is this going to become a problem, gentlemen? No, seriously. Okay. So an equilateral polygon has all congruent sides. Just like an equilateral triangle, all three sides were congruent. It doesn't matter how many sides it has. Equilateral means equal sides. Also, equiangular is a polygon that has all congruent angles. That's pretty easy because angle is right there in the middle of the word. Now, what we haven't talked about before is a regular polygon. A regular polygon is both equilateral and equiangular. Now, a little bit about English for a moment. There are two different ideas behind something that is regular. One is, if something's regular, it's just ordinary, right? It's just a regular old car or this regular old whatever. It's just ordinary. But the other idea of regular is that everything is perfectly spaced, right? For example, the bells ring at regular intervals. The interval doesn't change, okay? Or anything that happens time after time after time on a regular interval where the interval doesn't change. We go to church every Sunday. We go regularly. That means you go every single Sunday, okay? So the idea of regular here is that everything is even. All the sides are congruent and all the angles are congruent. So this, by the way, you could call it a regular quadrilateral. But what's its more common name? What is this? It's a square. This is an equilateral quadrilateral. That's an equilateral quadrilateral. What's its more common name? It's a rectangle. This is an equilateral quadrilateral. This one's a little less commonly known. What's the common name for this? It's called a rhombus. We will study rectangles, squares, and rhombuses in more depth a little later in this unit. All right. Now, for triangles, you already know a whole bunch of things about them. Like, for example, what do the angles in a triangle add up to? 180. But do you know what the angles in a polygon, let's say, what do the angles in an octagon add up to? You don't know that right off the top of your head, do you? We're going to talk about how to find those. So we're actually going to go through a little activity. I apologize that this got run on 2 pages. It only needs 1. So I'm giving you a free sheet of paper. You do with it what you want. So this investigation shows you a way that you can figure out the sum of the angles of any polygon, as long as it's convex. If it's non-convex or concave, where one point, pushes to the inside, it doesn't work very well. But here's how it works. You start with the polygon. This is an octagon. Is it a regular octagon? No. But it's still an octagon because it has 8 sides. You pick a vertex. It doesn't matter which one. So pick any point on the octagon and draw all of the diagonals from that vertex. So in this case, you would draw these 5 diagonals in. Each of those is a diagonal. Then count how many triangles you have. In this case, you have 6 triangles, right? What do the angles of one triangle add up to? Already asked and had this answered before. Everyone's heard it. What do the angles in a triangle add up to? Say it louder, please. Thank you. 180. So there are 6 triangles, and the angles in each triangle add up to 180. So you multiply 6 times 180. In an octagon, the angles add up to 1,080. So let's do this for some other ones and see if we can find a pattern. So here we have a pentagon. Pick a vertex, pick a point, doesn't matter which one, and draw on all the diagonals that you can from that point. You should be able to draw in 2 diagonals from that point. We have 1, 2, 3 triangles. So the sum of the angles is going to be 3 times 180. Which is 540. So let's fill in this chart. The pentagon has 5 sides. It has 3 triangles. And its angles add up to 540. All right, let's do a hexagon. Pick one of the vertices. It doesn't matter which one. Draw on all the diagonals from that one vertex. Count the triangles. There are 4 triangles. So the angle sum is going to be 4 times 180. Which is 720. So for a hexagon where there were 6 sides, there were 4 triangles, and so the angles added up to 720. All right, let's do a quadrilateral. Pick a vertex. Draw on all the diagonals. Now that doesn't take very long. There's only one. Count the triangles. There are 2. So the angle sum is going to be 2 times 180, which is 360. And then a heptagon, that's got 7 sides. If I pick a vertex and draw on all of the diagonals, there's actually a fair number of them. And then count the triangles. There's 5 triangles. So the angle sum is 5 times 180, which is 900. So at the heptagon, 7 sides, 5 triangles, 900. Now this is all fine, but what if I gave you something that had, I don't know, 37 sides? That's going to be horrible, right? Trying to draw a polygon with 37 sides, it's going to take a long time. It's going to be really messy. There's got to be a better way, and there is. I want you to notice something. There's a relationship between the number of sides and the number of triangles. So when we had 7 sides, 5 triangles. When we had 4 sides, there's 2 triangles. When we have 6 sides, there's 4 triangles. What do we have to do to the number of sides to get the number of triangles? Subtract 2. Exactly right. So the number of triangles is the number of sides minus 2. So if my polygon had 9 sides, how many triangles is it going to have? It's going to have 7. If it has 23 sides, how many triangles is it going to have? 21. So if a polygon has 9 sides, it's going to have 7 triangles. So the sum of the angles would be 7 times 180, which is 1,260. So if n stands for the number of sides of a polygon, the formula, and I'm going to add the word angle in front, I should have put that, the angle sum is equal to, first, I take the number of sides minus 2. Then we multiply that times 180. And that works for any convex polygon. All right, let's go back to the notes. So the sum of the angles of a convex polygon with n sides is n minus 2 times 180. So find the sum of the measures of the angles of a decagon. How many sides is a decagon? 10. You will have to know that on the quiz and on the test. Excuse me. So the angle sum is going to be equal to n minus 2 times 180. I always suggest that when you learn a new formula, you write it down every time you use it. If you do, you'll memorize it quickly. There's 10 sides, so that'll be 10 minus 2 times 180. So that's 8 times 180, which when you multiply it out is 1,440. Okay, that's one type of problem you could be asked. Here is another type of problem that you could be asked. Gives you this figure and asks for the measure of angle E and angle N. Now, please don't tell me that angle E is x plus 10 and angle N is x. We already know that. Forget this problem for just a second. If I gave you this problem, what would you do with this to figure out what x is? Yes, Gabby? Yes, exactly. You would add all these together and set it equal to 180 because in a triangle, the angles add up to 180. The only thing that's different about the problem that you have here is you're still going to add all the angles together, but they don't add up to 180 now. You've got to figure that out first. So it's just an extra step. So the angle sum is going to be, there's 5 sides. So 5 minus 2 times 180. Pardon?
580?
No. Try again. You're close.
Oh, 540?
There you go. 540. Very nice. So I'm just going to add all these angles and set it equal to 540. So let's see. Starting with P and working my way around, that's 100 plus x plus 10 plus x plus, what's the measure of angle T? 90. Gerson, you with us? You okay? I know, it's a tough transition back. Is equal to 540. We're on the next page. So let's group the like terms. There's 2 x's. And 10 plus 90 is 100, plus the other 100 is 200, plus the 120 is 320. Subtract the 320. We get 2x is equal to 220. So x is 110. So the measure of angle E would be 110 plus 10 is 120. And the measure of angle N is just x, it's 110 degrees. The third kind of problem that we can do with this formula is this one. Find the measure of each angle. That means each individual angle of a regular nonagon. Well, if it says they're regular, that means they're all the same. But first I need to figure out, well, what do they add up to? So the angle sum is n minus 2 times 180. So it'd be 9 minus 2 times 180. Let's see. That's 700 plus 560 is 1260, I think. Please, if anyone can, check my arithmetic on that. I don't always do that correctly. I think that's right. So then each angle, well, if there's 9 of them and they're all the same, we're just going to divide it up evenly. 1260 divided by 9 is 140 degrees. Any questions about that example?
I think the 5 times, it was like, was it 5 times 180, or was it like,
It would be 7 times 180.
oh, okay, never mind.
Okay? All right. Then the last thing for today is this idea, and we'll do a couple of example problems. This says that the sum of the exterior angles of a polygon, remember an exterior angle is where it's outside of the figure just by extending one of the sides, is 360 degrees. If I add these 5 exterior angles together, it's going to be 360. And it doesn't matter how many sides you have. The angles always add up to 360. So here's an example of the type of problem you might be asked. Find the measure of each exterior angle of a regular hexagon. So the exterior angle sum is always 360. There's no work to be done on that. The exterior angle sum is always 360 no matter what. So then each angle, we'll take 360 and divide it by, it's a hexagon, so how many sides does it have? 6. So we'll divide by the number of angles, which is the same as the number of sides. Each angle is going to be 60 degrees. All right, one last example. Here we're simply going to find the value of x. We've got an exterior angle at each vertex. The exterior angle sum is always 360. So I've got 10x plus 5x plus 7x plus 8x is 360. Combining the like terms, that's 15x plus another 15x is 30x. So x is equal to 12. All right, tonight's assignment is in your book. You've got about 7 or 8 minutes left. You can at least get started on it, if you would please.